Yeah, so today's problem is best time to buy and sell stock, lead code number 121. So here what is given is the stock price is given as an array on on the progressing days. Like 7 is what first day stock price, then 1 is second day stock price, like this, like so on. So here we have to return the maximum profit we can achieve from one transaction. Remember, only one transaction. You can buy on any of the day and you can choose another day in the future to sell that stock. So we can do only one transaction, and yeah, so we have to return the maximum transaction. So as usual, I will be discussing two approaches. One is the brute force approach and another is the optimal approach. For the brute force approach, I will not be implementing, just discussing the idea and the time complexity and space complexity. But for the optimal approach, I will be discussing the code as well. Yeah, so now this is the test case like 715364 and answer is 5. So this is already here in the OneNote. Okay. So now let's see the brute force approach. Like the 7 is there, 1, 5, 3, 6, 4. Okay. Here we'll have our answer variable equals to 0. And what we'll do is we'll have two loops. One as outer loop starting from 0 and going till n minus 1 as the price is dot length. Okay. And inner loop from I plus 1. Like if this is I, then we'll have j equals to I plus 1. This will be j for that I. What we'll be doing is I will be the buy day and j will be the sell day. So we'll do math dot max of answer comma sell minus buy. So sell minus buy is the actual profit. So 1 minus 7 is what? Minus 6. But that is not greater than 0. So answer will keep that as it is. So for any of this ith, for any of the jth value, 7 is the greatest number. So we cannot have anything greater than 0. So this iteration will means go on and will not update the answer. So for what value we'll have the answer is when I becomes this, like I becomes this, then we'll have j as here. And when this j moves to this place, sixth place, okay, when j moves to this sixth place and I is at this place, we'll have prices of j minus prices of I. 6 minus 1, 6 minus 1, 5 is the profit, which is greater than 0. So we'll update the 5, which is as good as the our output of the test case. So this is two loops are there. Each loop contributes to big O of n. So time complexity will be big O of n square because they're nested loops. So n into n is n square, and space complexity is big O of 1 because we are using constant number of variables. So this is the brute force approach. Now I will be discussing the optimal approach. Okay. And if you want me to quote the brute force approach as well, please do comment in the comment section. Okay, now let's see the optimal approach. 7, 1, 5, 3, 6, 4. Here, what we'll do is we'll have two variables. One is the minimum. Minimum indicates the minimum buying of stock. Okay, so 7 is the min because initially we are. It is given in the question. It is given in the question like prices dot length constraints is at least 1. So that means there is at least one day in the prices. So we are having min equals to 7 and answer equals to 0. Okay. So here what we'll do is we'll have our I variable here and we'll do answer equals to prices of I minus min, means mat dot max of answer comma prices of I minus min, where prices of I is the sell day and min is the least price of the preceding days. Okay, least price of the preceding days, and prices of I is the sell price. So sell price minus least price is the profit. So 1 minus 7 is what? 1 minus 7 is what? Minus 6, but 0 is greater than minus 6. So we'll not update, we'll not be updating the answer equals to minus 6. What we'll do is we'll go and move forward. But before moving forward, since this is 1 and min equals to 7, what we'll do is we'll update this on min equals to 1 because 1 is now minimum than 7. Then we are having this I here. After updating the min value, we are having this I. Now I points to 5. Then prices of I minus min is 1. So 5 minus 1 is 4, which is greater than 0. So we'll have this 4. 4 which is greater than 0. Now we have again min, we have to update the min which is 5 and 1. So 1 is already minimum. Okay, then we'll move ahead. Now prices of I is 3 minus min is 1 2 which is not greater than 4. So we'll again move forward, but before moving forward we have to update the value of min. Now this is 3 and min is 1, so min is already minimum, so no problem. Then we'll come here. Here prices of I is 6 and min is 1, so 6 minus 1 is 5 which is greater than 4, so we'll update this 4 and we'll update this answer and make it 5. Then we'll go, and before moving forward, as usual, we are updating the min. This is 1 and this is 6. Now what we are doing is we will go and check for the last round. This is 4 and prices of I is 4, min is 1, 4 minus 1 is 3 which is not greater than 5. So 5 is our final answer which is validated with our test case. So this is, see, in a single loop we are able to do the maximum profit. So time complexity is big O of n, space complexity is big O of 1 because we are using constant number of extra variables. Okay, so this is better than our brute force approach. Now let me try and write down the code for the optimal approach. Min equals to prices of 0 as we are doing as we have done in our dry run. Answer equals to 0 for int I equals to 1, I less than prices dot length I plus plus. So here answer equals to math dot max of answer comma prices of I minus min. And now before moving on to the next iteration, what we are doing in the dry run was min equals to math dot min of min comma prices of I and returning answer from here. Now let me run this test and see if there are any compilation errors or not. Then we'll submit it. Yeah, so the sample test cases are running fine. Okay. Now we'll submit it and check whether this problem gets successfully submitted or not. Yeah, so this is getting accepted. So that's it for the problem. If you're liking my video, please do subscribe to my channel. Yeah, so that's it.